Perfect. Yeah, I think we're live now. We'll just give a couple more seconds, like 20 seconds now, and then we can go from it.
Sounds good. Oh, yeah. Hey, everybody. I'm Zach. I'm the lead engineer for Kubernetes optimization at InOps. Thanks for joining us today. I'm happy to talk with you about some common industry challenges that we've seen at InOps, like Spark right sizing on Kubernetes and multidimensional autoscaling on Kubernetes, which I know is a hot topic. And we have some interesting solutions to present today.
Awesome. Hey everyone, this is Shari. Zach and I work closely together around EK scaling and optimization tool. We have been developing this tool in-house for like almost like three and a half years. And this talk comes directly from what we have learned, what we have experienced, and what are the common problems that we have seen. And we ourselves have experience while running certain type of workloads in our productions and also helping customers during their migration process and how do they work with different kind of workloads and stuff. And our goal today is, share these stories and experiences, what's hard, what works, what doesn't work, how can automation help us, and what's the advantage or the savings we can get from automation or stuff, and how it can offset a lot of work from our side. So these are like broad challenges. These are the things we'll be talking about today. And jumping into housekeeping, there are a quick couple of housekeeping items. Today's LinkedIn Live will be 30 minutes, around 30 minutes, and we'll start exploring around two topics that we were just discussing, around Spark and HPA and VPA challenges in general, and the common practical strategies that you have to use and common myths around it, whether they can be used together, cannot be, when they shouldn't, etc., and stuff. And we'll be taking questions from audience. We are live on LinkedIn, YouTube, as well as X. So you can drop your questions in the comments. They will pop up here, and we can look into them and answer them if we get time. And lastly, today's session is being recorded, and it will be available on LinkedIn. So you can view it again or share it with your friends or colleagues, just to go through and brainstorm around like these common problems if you have them. Quickly jumping into the two challenges that we have been talking about. So the first challenge was Spark optimization. And how can I do Spark optimization? There are many ways to run Spark, many places to run Spark on, which is the best optimized strategy or ways to run it, why we should run it, and how we should run it, and how can it be cost effective to make it way better and easier to use. And the second challenge that is irrespective of Spark or not, the second challenge that people commonly experience or face is autoscaling within Kubernetes. We are talking about pod or container autoscaling, not the node autoscaler, but
Right.
more around like, hey, what are the common kind of practices that we have around like whether we should use HPA or we should use VPA or we should use KDA, we should use some event-driven approach. How can we use it? When we should use it? How should we plan it? How should we architect it? And can we use all of them together or can we not? What kind of automations or open source tool we need to use? These are the common things we'll be discussing in the autoscaling topic as well. So these are the things we'll be covering. Please let us know if you have any questions around those things.
Yeah.
Again, the first thing will be jump into Spark optimization. So first thing would be, yes, as we discussed before, Spark can be run in many places with like in a managed service, like, you can also run it in EMR in a certain way, and you can run it in your own environment on standalone EC2 instances. And there's another way to do it, which is like, hey, can I do it on Kubernetes as well? And why we should even do it on Kubernetes when I can do it in a managed service and stuff. And a very common thing or very common big reason when people want to run on Spark on Kubernetes is unification, right? Instead of Spark living in its own managed world, again, Spark is not just like a single application that you deploy and it's done. If tuned properly and if it architected properly, it's very streamlined application that you don't need more or overhead or more kind of oversee for that one. But if it's not architected properly, which we've seen in the real world scenarios, and if it's not deployed properly as well, it can lead to cost going haywire and being a very huge managerial overhead. and that becomes a huge issue for customers in cost wise and also time management wise because of the hands-on help that Spark will need. And that's one of the reason people run it on EMR clusters or in Databricks or workspaces, etc., and stuff to make it easier because they are managed service. But again, it comes with a cost tag associated, right? So it becomes part of same Kubernetes platform that already runs in your application, where your applications and services run if you run it on Kubernetes. So you already have everything in one place in one go instead of using a managed service and paying more money. You can just have everything in one place, one go. This means one environment for compute, networking, security, and monitoring. You don't need to deploy complete end-to-end VPC layers, and also security layers just to get Spark to communicate with the existing, platform. So this integrating into Kubernetes makes it way easier for platform engineers or DevOps or infra teams to manage. And data teams and platform teams speak the same language when it comes to infrastructure management or overhead. Any thoughts around that, Zach? Any things you want to add on top of it?
Yeah, I mean, I think that so let me preface it with this. If you're already invested in the Kubernetes ecosystem, unifying Spark onto your Kubernetes clusters can pay off in a lot of different ways. Like you mentioned, it can pay off in the management overhead because if you're already heavily invested in Kubernetes, you already have CI/CD pipelines, you already have observability around Kubernetes. All of that basically will apply to your Spark usage if you're deploying Spark on Kubernetes. And you have a lot of opportunity to optimize for resource utilization and cost optimization if you run Spark on Kubernetes as opposed to a hosted platform, because it becomes Spark jobs become just another Kubernetes workload. So you can use all of the existing Kubernetes facilities to manage where they run. You can deploy them on spot instances, you can deploy them on on-demand instances, and you get access to all of the same auto-scaling functionality that you are already relying on to optimize the resource utilization of your Kubernetes workloads. You can apply that to Spark.
Yeah, of course, platforms like EMR or Databricks may keep productive from day one. Yes, it's less hands-on,
Right.
but
Yeah.
they're always well integrated and easy to scale. But you pay for that convenience. It's like a SaaS, right? You're paying for that convenience higher than what you can actually be paying compared to managed ones. And it can be tough to tune resource utilization to see where you can optimize or where your inefficiencies are once it becomes a managed solution. You don't have much tweaking to do or much knobs to turn to make it optimized in every point of view, right? And on Kubernetes, when you run them on Kubernetes, right, you get that control back where you can track into each and every metrics and each and every resource utilization, and also introduces new challenges, which we'll talk about one of those things next. But it does give you more visibility and more kind of knobs to turn just to tune it efficiently, so
Right.
that the cost difference can be way higher, like 60-70% in some scenarios. And to generalize this, right, I think we can talk it more in the next slide, which is this one, which Zach, I
Yeah.
guess. Yeah.
So this is the optimization problem that you face when you deploy Spark on Kubernetes, right? So this is not the day zero problem. The day zero problem is getting it up and running. Things like Spark Operator can make that pretty easy. So this is assuming you've got Spark Operator running, you're starting to run your Spark jobs on Kubernetes, and the next problem is, well, how do I optimize this? And this problem really originates in the ephemeral nature of these jobs, right? Every time you submit a Spark job, Kubernetes spins up a fresh set of pods. There's driver pods and executor pods. They do their job and then they're gone. They're cleaned up. They're terminated, which is great. Like that's how it's supposed to work. Everything's ephemeral. This is a win for your resource utilization because you can schedule things. If you schedule things well, you don't have idle nodes out there waiting like you might if you were using EMR or Databricks. But it can become really hard to answer questions about what resources are typically used.
Yeah, exactly. For example, right, if you are trying to answer a question like, hey, what's the memory utilization on the driver node, or how it's fluctuating over the time, or how much even, like, doesn't care about the node, but how much it's using compared to, like, what's it requested. It's hard to track them. I just know the usage over the time, but I won't know what's the actual resource underneath infrastructure being utilized, how much of it is being utilized, right? And for example, if I want to know how much memory or metrics around like a specific job, it's kind of hard to track them down. It's not easy. And also because the data for each run lives and dies with those spots, Prometheus create metrics, but those metrics and those cities and as the moment the pod terminates, right, the metrics are gone too. Like there is an end for that metric. There is no continuation for that metric first ever. It doesn't matter how many times the job runs. It's completely different job in a unique point of view, right? But the next time they run, we are unsure how to tune these as they keep changing the actual pod IDs or any of those things. They change every day, and grouping them or aggregating them or rolling them up becomes a very new challenge. And it's like a completely new job, completely new environment every day. Unless these jobs are running for like over like 1 week of time, then yeah, that makes sense to tune them. But again, that comes another problem. Like, okay, I got the metrics, but how can I tune it when a certain container is running for over a week? They want to terminate it and rerun it to make it optimized. Well, it's not cost efficient because you're rerunning the whole job end to end again. So it's kind of like, not very efficient if you try to go and get the metrics yourself. And even if you get it, it might get efficient one day, but it might not,
Right.
because you're paying for rerunning the whole pipeline again.
Right. Yeah. I mean, I think really the challenge is that observability systems around Kubernetes by default look at, they're tied to workloads. They're tied to individual workloads. And your Spark jobs, while logically you understand that they are the same workload, they look to Prometheus like they're a bunch of individual workloads that blip in and out of existence. So if you're running hundreds or thousands of these short ephemeral Spark jobs, you end up with this sea of one-off metrics. Uh, so I mean that's not an insurmountable problem, but if you're facing that problem, like initially your right sizing is just going to become guesswork
Ex-
without a lot of hand work and hand tuning of PromQL queries or something like that. You can't really build trends, and it's hard to do historical analysis. And it's also hard to tell whether or not your tuning has been effective, because you still need to do that aggregation to tell whether your tuning has been effective.
Exactly, because you also need to bind them to the cost. It's like, okay, sure, yeah, I reduce my request, I change my usage patterns, but it has to tie to a cost at the end of the day. Yes, there are open source tools out there, but we have seen teams manually exporting these kind of metrics and parse logs and even run their own SQLite databases just to track their performance job per job, right? It's tedious. People might say, "Oh, I can use managed Prometheus." Yes, it's very expensive. Managed Prometheus on AWS can get very expensive very quickly, and people don't know how to solve it because of the number of dimensions of data that you're looking at, right? And it's fragile and tedious, right? It's not just about managed Prometheus. Even if you go with your own way, there is no feedback loop, as you mentioned, Jack. And also, it's fragile and tedious. That's what motivated us to build something more systematic and more optimized, right? That's what we
Mm,
want to look into. And jumping into the actual common workarounds for that, right? Okay, what are the things if I want to go with a open source strategy? How can I make it better and stuff, right? Most people try to patch this problem with whatever they have, right? It could be Spark History Server that already exists from open source, and they want to try to, uh, gather the data from it by extracting the timelines and stage durations and but it does not give you resource utilization, right? It gives you how much time a job ran and stuff, but not the resource utilization, which is
right.
the ultimate goal where you can optimize the resources, right? And Prometheus give you live metrics, but not across multiple runs. It's obviously it does consider each run as a single one-off item and a new workload, so it cannot combine or replicate. And that's where the third step comes in, which is manual tuning, which I will let you talk about.
Yeah, I mean, you can certainly do manual tuning, and you can use some of the data from Spark History Server, and you can get clever with your PromQL queries, and you can do some manual tuning. But the problem is that often these data-driven jobs, they're duration and their resource needs vary depending on the data set that they're being fed. And that can vary seasonally, that can vary based on your business trends. There's a lot of different things. So manual tuning, you either do it once or twice because it's hard and you don't have the right tools to do it well, and then you end up with a configuration that works sometimes and wastes money other times, or you dedicate people to just manually tuning your Spark all the time to follow the business trends, and that's expensive.
Exactly. The most expensive part for a company is not the resources they're on a cloud, it's the humans that are working to keep the
Right.
cloud up and running, right? And you might optimize one long running ETL job and make everything else worse. It does not fit the formula of like, optimizing everything end to end, right? Without aggregated visibility, you're still tuning in the dark. There is like absolutely zero guidance on which way to go, where to go, whether you're doing it right or wrong, right? That's where the approach and it started to change things on how you need to think on how to optimize these things, right? That's where NOps has a better way to do it, which is like, uh, we aggregate all your cost across multiple runs, which Zach will be talking about more around like the formula of NOps on optimizing the Spark jobs.
Right. Yeah. So, I mean, we're building on the platform of our existing container right sizing product here. So, we already have those metrics for our customers. But our first big idea was that we recognized that aggregation was key, right? We need to treat multiple Spark runs of the same logical workload as a single entity. And so we can call that an application profile. And we use hooks into Spark Operator to do that automatically and make sure it's reliable. So every time a workload runs, we capture the metrics, we CPU and memory utilization and some other metrics. But CPU and memory utilization are critical because they're the cost-bearing metrics. And we roll them up for that logical workload. So the same Spark workload we aggregate across all runs. So it's no longer these siloed ephemeral things. It is a continuous time series of data across that logical Spark workload.
Yeah, exactly. This lets us build like a complete timeline of a specific job, right?
Yes.
It tells us we are building something really powerful because I can continuously say a performance history of a certain driver or certain job, certain workload, certain run, right? Over time, we can say that, hey, this application used to run this inefficient, this 90% inefficient, and now it's only running 10% inefficient. That means you had an efficiency gains of 80%, right? And you can give an example like, hey, this application used to peak at 4 cores and 8 gigs of memory. And you actually can say that now because you have that historical analysis right now with a timeline. You can say that this specific application, yes, this peaks around 8 cores, but in general, it only runs around like 4 cores at the standard times. But 90% of the times, it's 95% of the times, it's a 90% usage, right? And it has a pretty predictable load right now. And suddenly, right sizing becomes a data driven process instead of a guessing game compared to what we have discussed just a few minutes ago, right?
Right.
And this has to be continuous process at all times.
Yeah, and because we're doing this at the metrics level, not a Spark configuration level, you don't actually have to modify any of your Spark job code. Like we're not hooking into your job code. We're doing this at the Kubernetes metrics level and the Spark operator level. So this aggregation happens automatically as you run your Spark jobs. And the longer the system runs, the deeper our history gets on your Spark jobs and their utilization, and the better our recommendations get.
Exactly. It's like giving Spark a memory instead of each run being one off. We are connecting all the dots, giving you the stable, continuous environment around it. That's what we want. We will do around with Spark optimization. It's pretty
Yep.
easy. We can talk more about it. If you have any questions, just drop them in the comments. We can go over them, and you can also reach out to me, and we can have a call and we can talk more about it to see how
Yeah.
your environment is running, and we can jump deep down. That's around like Spark optimization. Now I want to talk about the second common challenge and second topic of this webinar that we introduced in the beginning, which is what's the right approach for scaling your containers within your clusters. And Kubernetes scaling isn't just one thing; it's an ecosystem itself, right? We have got HPA, we got have VPA, we also got KDA, and we also got which is KDIs, which is nothing but an event-driven approach, right? And we also got node-level scalers, which is like, cluster autoscaler and Carpenter for EKS, right? And again, one of the main thing that I want to mention here, I have met many customers around, like, the first thing I asking, hey, what kind of pod autoscalers are you using? And they tell that, oh, we are using Carpenter. It's actually not a pod autoscaler, it's actually a node autoscaler. And this is a common misconception. Some of the people and the number of engineers or platform heads I meet, they're not very aware of what kind of management they want within their clusters. Yes, Carpenter is great, but it's a node autoscaler. It's not actively managing your pods, right? But if you think that you just deploy a long running pod, that's completely fine, but that's not an autoscaler. It's not like scaling up, scaling down. It's standardly running like 10 pods continuously without any metric tracking, and you're just wasting money there, right? That's kind of like, why importance of pod autoscalers. And uh, it's very important to have them if needed.
Yeah, I think you're missing if you are only scaling at the node level with Carpenter, you're going to miss out on a lot of cost optimization opportunities and performance optimization opportunities. So I think it's critical that you operate at both the node level and the pod level. And I think for this discussion, we're going to focus on pod level autoscaling.
Right, yeah. But what happens after the conflict? Like VPN increases the pods, and we will be downsizing it. Like VP and HPA cannot go together. That's very common, man. Like, because hey, if my HPA is adding more and more containers and VP is like right sizing them bottom wise, it's just not very efficient, right? And you have to have a proper line drawn between both of them. And if you don't draw it, suddenly with making HPA and VP working together, they can increase the resource footprint, increase your cost very quickly, very easily. And if it's not done properly, it's a nightmare for platform engineers. And that's where our approach comes in, where Kira with VPA is the best approach in general, but obviously Kira is a paid service nowadays and people don't want to use it. Well, that's where ops can deliver you, hey, okay, that's fine, we can work with HP and VPA together without you being in that position and being in a situation where you have to spend a lot of time managing them or tuning them, right?
Yeah.
And autoscaling in 2 dimensions is what we were talking about, right? Like, hey, okay, this is nice, we can have both, but when should I even use both? Or when should I even use one, right? This is a great graph. In Kubernetes, scaling happens in 2 dimensions, right? And the vertical, when I say Kubernetes, I'm talking about pod for the remaining context of the webinar. In
Yeah.
pod autoscaling, we're only looking at 2 dimensions. It's either like horizontally add more boxes, which is nothing but container supports, size the boxes up and down. Like I want a extra large box, or that means like hey, increase my resource, my pod CPU to from 1 CPU or half a core of CPU to 20 CPUs. That's like vertical sizing. Or just keep it one core per box, but add more number of replicas, becomes your HPA, right? And that's the main autoscalers in that's the main difference between these two pod autoscalers.
Right. Yeah. And often, I mean, I think the common practice is to limit automatic scaling, especially to one dimension or the other. You may have an application that is a legacy application and it doesn't scale well horizontally, so you just focus on vertical scaling. And I mean, having one autoscaler is better than having 0 autoscalers, so maybe that's a win. But or you have a very modern application and you're really concerned about load following, and so you focus on horizontal scaling using HPA or KDA to follow load. Also great, but if you just lean into that, you're missing out opportunities that you could get if you can combine the two.
Exactly, right? Like you might shrink pods to save money, but now you need twice as many to serve the purpose, right? And if you expand pods and trigger node autoscaling because they no longer fit on existing nodes, the system oscillates between these 2 dimensions until they are coordinated. It just keeps going haywire, right?
Yeah.
And yeah.
Yeah.
And,
So we like to visualize it on this plane, so you just help you keep things straight. So vertical axis, more CPU memory; horizontal axis, more duplicate.
More replicas.
More
exactly.
replicas, yeah. So obviously there's trade-offs here, right? And historically, this multi-dimensional autoscaling problem has been regarded as very difficult or perhaps even unsolvable. And but we're engineers, right? So we make some practical assumptions and we look at some real world cases and we find, well, if we make some practical assumptions in real world cases, this is not an insolvable problem. And so our opinion at InOps is that if you have a well-designed cloud native app that is somewhat tolerant to a few disruptions and scales well horizontally, you can use multidimensional scaling. You can use vertical scaling to get your best resource efficiency and cost optimization, and you can use horizontal scaling for load following. So you tune each replica to have high utilization of the available resources or the provisioned resources, and then you scale horizontally when you experience load spikes.
Exactly, right? Like you need vertical, in a simple words, right? In Kubernetes, vertical right sizing is when you, or VPA is when you have a very predictable and consistent workloads, and you need horizontal, or horizontal shines the best when the load varies by time, date, and data volume, etc., and stuff. But coordinating both means can respond. You can to respond and stay efficient with both coordination at the same time, right? So that's where
Yes.
we have to look.
And I think the coordination has been the historical challenge here, right? Now there are some really great ways to handle this using open source tools. For example, if you want to use VPA in conjunction with CADA or in conjunction with HPA using custom scaling metrics, that is a great way to approach this problem because because you're scaling based on, instead of scaling based on CPU and memory utilization horizontally, you're scaling based on signals that actually matter. Like what's your load balancer network traffic or something like that. And then you don't have an inherent conflict between your VPA and your HPA. So the you either need to remove the need to coordinate or you need to have some way to coordinate HPA and VPA. And that's sort of where our approach comes in. Yeah, so our system actually uses our data pipelines to coordinate HPA and VPA so that they don't fight. The VPA tries to maximize the resource utilization on a per pod basis, and then we intelligently set scaling thresholds in the HPA so that the HPA will stay out of the way and will only scale horizontally when you actually experience significant load spikes beyond your normal operating conditions. So um, you get the best of both worlds.
I mean, like this, when you said that, right? This exactly means that you're not blindly reacting to instantaneous CPU spikes. Rather, the auto scaling nodes, these workloads are typically at 2x baseline, so it can adjust these thresholds accordingly. It smooths the oscillations and prevents this overreaction of overcommitting, or like spinning up nodes randomly, or instead of adding more CPUs or more replicas, things manually instead of reacting to it blindly, right? And yeah, we also propagate that down to the node layer as well, which we do try that. So we do in syncs across multiple dimensions.
Mm-hmm. Yeah. So this is a feedback loop that learns over time based on our right sizing engine and keeps your HPA and VPA from fighting each other with intelligent coordination.
Yeah, and think of this as like a feedback loop that learns, right? Like each run, each scaling event, it's not blindly adding things,
Right.
rather making the next ones more efficient. That's the reason. As soon as you install our agent, we actually don't ask customers to turn on right sizing on day one because, hey, the system needs to learn. The higher or the older data we have, the maximum is 30 days to look at. So even if it has like 1 week of data, right, it's very efficient and it can learn over the time. Within 1 week, we can learn a lot of scaling events, a lot of activities around your cluster to tune it properly.
Right.
And to make it very simple on how does our approach will result in, right? This is like a proper before and after kind of scenarios where you can see that, hey, this is in practice on the left side before you actually got oversized costs, underutilized nodes, unpredictable job times, bursty workloads. And on the right, you see a steady utilization of smaller pods and fewer nodes over the time, right? And this one will make your cluster breathe naturally, in the sense like instead of adding like nodes, tens and hundreds of them within like a minute, and just goes away, rather than that over the time it smoothens the workload. Try to get those spiky workloads, but not very too high in spikes, but very natural spikes that hey, it's expected because it's overutilized at certain times and stuff, right? And that's what we're trying to achieve.
Yeah, and the stability isn't just about saving money, though you will save money with that. Or it's it's about predictability. I mean, it's about keeping the system functioning smoothly, making it easier for you to hit your SLAs, making your clusters more responsive to your business, and saving you money.
Exactly. So that comes us into our automation kind of process. What are the common ways to help, if not in ops, or what are the common ways to look into or way to look at, right?
Yeah, I think the foundation here is metrics. So if you're starting day zero with automation, get a good metrics pipeline in place, collect everything. That is the foundation for everything that InOps does as well. And then the next level is insights. So you need to be able to aggregate data in a meaningful way. And then once you have that aggregation, you can start thinking about that aggregation and those insights will help you make better manual changes. But once you have those insights available, you can start looking at automation. And the more you automate your actions, the more savings you'll see.
Yeah, exactly. The trick is transparency, right? Like making sure you see why the adjustment is needed or when it happened. And we have built automation in a way that it's explainable. It's not like a blind automation. It's trying to like look at
Yeah.
blindly the data. It rather reads the metrics in all kinds of scenarios, and it's explainable automation that can be because it has a feedback loop, and it also has the right sizing engine making these decisions. It is an explainable decision on what basis it made that decision. And every scaling changes, every kind of change that NOps pushes will be traced back to your metric, or to a trend, or to a right sizing event on why we did it and stuff, right?
Yeah. So we with InOps, you can trust our decisions because you can audit them and you can override them if you need to. We want to amplify your judgment as an engineer, not replace it.
Awesome. So that's coming. That's to the end of the session, guys. If you have any questions, please don't forget to drop them in the comments. We're happy to answer your questions, and we're also tracking the questions on X and YouTube as well. That summarizes the whole Spark metric aggregation on how we do Spark up workload optimization on Kubernetes, and also how we also do like uh, multi-dimensional autoscaling as well. Looks like we don't have any questions today. Lucky day for us. Zach, we really appreciate everyone's time. Have a wonderful day, guys. Thank you.
Yeah.
Bye-bye.
Thanks for coming.